You are watching the 1.4 lesson video on writing equivalent equations. This is just a fancy way of saying we're going to be solving equations with lots of letters, lots of variables, and we need to get one letter alone or one variable alone on one side. So right now, if you look at all of our examples, we have an example that just deals with a normal equation, and then what we're going to be doing together is solving for variables. We are going to use inverse operations. It looks scary, but it's actually not so bad, and you don't have to do as much math because a plus b is always going to be a plus b, where in math, if you have 5 plus 7, you have to add those two numbers to get 12. Okay, so number 2. Example number 1's been done for us. We're trying to get x alone, so we just added 4 to both sides to get x is equal to 14. Now, for us, we're trying to solve for a. I actually think using a highlighter on this page is a really cool thing. So if you don't have one, you might want to bust one out now. So if we're trying to get a alone, we always want to think, why is a not alone? Well, b is being subtracted from it. And what's the opposite of subtracting b? Yeah, adding it. Oh, look at me zooming like a crazy person. Okay. We're going to add b to both sides of the equation. You're like, that's weird, but okay, this is what we do. So a is alone now. That's going to equal c plus b. C plus b. We can't add cantaloupes and bananas together to make banana, I don't know. So c plus b is how it stays. And we've solved for a. Solve for a means get a alone. Okay, see, not so bad. Let's look at example number 4. Well, in order to do 4, we're going to look at 3 and see that we're trying to get 2 alone here, or x alone here, so we divide both sides by 2 and get x equals 5. Here, we're trying to solve for r. It's being multiplied by a, and how we cancel out multiplying by a is, yeah, divide by a. So r is equal to v divided by a. Can we divide v by a and get something nice? No. So we're just going to write it as v divided by a and leave it. Okay, see, it's not scary. It looks scary, but it's not. Less math. I didn't have to divide a into v like I had to divide 2 into 10 over here on my example number 3. All right, number 6. Number 6, we need to solve for a. Why is a not alone? Well, it's being divided by L. How do you cancel out dividing by L? Yep, you multiply by L. And we have to do this on both sides. So LW is equal to, L divided by L is 1, so LW is equal to A. Or you could just write it as A is equal to LW. Oh my gosh, I know what that is. That's the area formula of a rectangle. So cool. Okay. Here we go. Number 7. We got to solve for x. Whoa. All right, there's more stuff going on in this one. I'm not going to freak out, but I'm going to do exactly what I've been doing. Solving for x. Got to get x alone. I'm going to use 7 to help me with this. Oh, I see. I subtracted that, that plus or minus something. Okay, so in this case it was plus 15, so I subtracted 15. We're going to do the same thing here. So we are adding c. So let's subtract c. Okay, what do we get? Ax equals r minus c. Okay, we still need to get x alone, so we need to divide everything by a. And when I say everything, I mean everything. So our final answer is x is equal to r minus c all divided by a. I'm getting crammed in there. Okay, and there's my final answer. And yes, we leave it like that. You know, sometimes you might see it written a different way. So like x is equal to r divided by a minus c divided by a. And all that's doing is breaking up that top, I guess your numerator, into 2 different fractions. So r is being divided by a, and so is the c, and then you're subtracting them. So you could write it either way. Okay, let's look at 10. 10, we are solving for r. Ooh, this one's a little spicy. We're squaring r. All right, first thing, what do we got to do? Looks like we gotta... Oh, so r is squared and it's being multiplied by pi. So we first need to divide by pi. When we solve, we're doing opposite PEMDAS, opposite order of operations. So a divided by pi is equal to pi divided by pi is 1, so we're just left with r squared. Now, some of you might be like, well, what on earth is the opposite of squaring? Well, look at your calculator. If I look at the squared key over here, what's the opposite of squaring? Look right above it. Yes, the square root. We are taking the square root of both sides. So, final answer, drum roll, r, because that cancels out with that. Square roots cancels out with squared. R is equal to a divided by pi and the whole square root of that. I'm being, I don't know, a little lazy and leaving r on the right-hand side. Actually doesn't really matter, just as long as r is alone, and it is. All right, let's move on to the next page. Whoa, what did I do? Okay, here we go. All right, page 20. Now, we're doing nothing differently. It's just sometimes worded a little bit differently. So 11 says find k. We're still finding k. Find k. Find k. And we're finding k in terms of p and d. All right, I got this. So if I want to get k alone, well, gross, there's some grossness happening. I actually have some parentheses here. And the only way I'm going to be able to get where I need to be is I need to distribute. I'm going to multiply d to both k and negative 7. So p is equal to dk minus 7d. All right, now we are still getting k alone. So in order to get k alone, we're going to add or subtract things first and then divide or multiply. So let's see. We're going to add 7d to both sides. So we get p plus 7d is equal to dk. Almost there. We gotta get k alone, so it's being multiplied by d. Divide everything by d. So we could, there's a couple of different ways that we could do this question, and it might be shown in a couple of different ways, so I just wanted to show you. First of all, the right-hand side is easy. D divided by d cancel out, so I'm just off with k. Now, I can actually divide d into both of these two terms in my numerator. P divided by d, well, can't do much with that. P divided by d plus, well, d divided by d is 1. So if I do that, those d's cancel, and I'm actually only left with 7. So that's one way of looking at it, if you get the d's to cancel. Another way, you could just leave it exactly how it is, p plus 7d, all divided by d, is equal to k. So not doing any of the individual dividing like I did over there. It's this or that, they are the same. Potato, potato, tomato, tomato. Okay, let's move on to 12. So find b sub 2, this little guy here, in terms of a, h, and b1. Basically, it's saying just get b2 alone. And here we go. You know, we have parentheses in here. It's similar to the one above, but I wanted to show you a little trick that is something that you could also do instead of distributing, is use your inverse operations to get the parentheses section alone. So the first thing that we're going to do is get rid of a fraction. And to get rid of a fraction, we can multiply, well, in this case, it's 1/2, so we can multiply both sides by 2. If it were 1/3, we could multiply both sides by 3. So here we have 2a is equal to h, all times b1 plus b2. Okay, now h is being multiplied to that whole chunk of parentheses that we're trying to get alone currently, so we can divide both sides by h. If I divide both sides by h, since that's a multiplication question right there, the h's actually cancel. We're not going to write it anymore on the right-hand side. 2a divided by h, no like variables, And we are just left with b1 plus b2. All right, almost there. Why do I keep doing that? Sorry. Oh my gosh, oh my gosh. What's happening? Okay, sorry, I think we're good now. My computer's freaking out now, and so am I. All right, we got to get b sub 2 alone. In order to do that, how are we going to get rid of that plus b1, or the b1 that's being added to it? Yes, you're right. Subtract b1 from both sides. Yeah, this is going to look weird, but who cares? 2a divided by h is equal to, oh, ew, what am I doing? I'm forgetting this. Okay, 2a divided by h minus b sub 1 is equal to b sub 2. Much prettier. And my h looks like an n. Much better. Okay, last one, 13. Don't hate me. I know I'm over the 10-minute mark. We're going to go through this one fast. All right, we have to get h alone. Let's do this. H has got to be alone. There's a nasty fraction out in front. I don't like it. So let's get rid of it by multiplying by its reciprocal of 3/4. And we know this because we've been doing this in solving equations. So 3/4 v is equal to, bam, bam, cancels out, yeah, pi r squared h. Still getting h alone. Ooh, okay. If we want to get h alone, what can we do here? What are we going to do here? We're going to make this look really ugly? I don't like this equation at all. Okay, well, I guess we could do this. We'll let it look messy. I don't think it's a big deal to have it look messy and gross, but maybe we'll address this in class. So we're trying to get h alone, so why don't we divide both sides by pi r squared? Okay, now the reason why I say I don't like this one is because I have fractions and fractions, which is typically not the route that we want to go, but you know, this is actually probably a not great example, and you will probably not ever see this on a test, but let's just go with it for now. 3/4 v divided by pi r squared. Another thing is I don't like 3/4 and pi in there, but what are you going to do? That will equal h. Okay, so don't stress out too much about this example. We'll probably see some better ones when we do the recap in class. But there you have it, our lesson video. Oh my gosh, I'm just going to stop and I'm just going to let it be on the side for the writing equivalent equations.